Hello. So here we go. Today we're going to go over some fractions. It's probably going to be about 2 days of this. So today we're going to go over multiplying and dividing fractions, and then we're going to go over adding and subtracting fractions tomorrow. Little joke on the left there. I find it funny. Fair enough if you don't. Here we go. So as always, a little starter there if you want to have a go. The left hand side is just basically the bare minimum of what we went over yesterday, and then the right hand side is basically as complicated kind of question I could think of. So pause video here, we'll go over it now. Okay, so just a quick recap then. If you're multiplying or dividing numbers and they have the same sign, your answer is positive. So here we have a -2 times a -5. That's just a positive, so it's positive 2 times 5, which is 10. If they have different signs, then it's a negative. So we have a -2, but we also have a +3. I know we don't put a plus at the front of it, but it is positive, right? So a positive times a negative is a negative, and then 3 times 2 is 6. -10 divided by -2, again, they got the same sign. It doesn't matter its division, it's still the same thing. So a negative and a negative, they're the same sign. So I'm just looking at 10 divided by 2, and that's 5. 8 divided by -4, that's a positive divided by a negative, so it's a negative. And then I know that 8 divided by 4 is 2. And then this is one of those where I said a lot of people in general get this kind of stuff wrong. It says -2 all squared, so it's literally -2 multiplied by itself, right? And then once you realize it's -2 times -2, you realize your answer is going to be positive, and then 2 times 2 is 4. This is one of those that messes up a lot of people. And this was kind of like my hint for you for the right-hand side. So let's have a look at this right-hand side. So again, we're doing BEDMAS. We have brackets, but we don't actually. Inside the bracket, it's just a number, right? The negative, you don't have to do anything with it, so there's no reason there. Then we have exponents, so we're going to do -3 times -3. That's what that means, which is 9. Right, I'm just going to write everything again. -3 times -4 plus 1. Then we have division and multiplication, read left to right, but we only have one multiplication, and that multiplication is the 3 times -4. I can't use the negative for the -3, right, because it's 9 take away 3 times -4, so that's what we have to do. So I'm just going to write 9 take away in front, and then 3 times -4 is going to give me a -12 plus 1. Then we had a big speech about how if I'm doing a subtraction of a negative, I'm technically just doing a plus. So it's going to be 9 plus 12, which is 21, plus 1, which is 22. And there's my answer. If you got 22 for that, well done. That was not an easy question. That was me basically just trying to throw as many tricks in as possible to really try to get you to make a mistake now. But obviously that means that in the test you won't make the mistake, hopefully. Anyway, cool. That's that. Now, I've spoke about how I teach in general, but I kind of just teach in a way that pretends that you've never seen anything before, and I kind of recap everything. The reason for that is I really think that even though, if you're really good at a subject, it's never bad to go over something again, because why not? And if you're not that good at it, well, then it's useful to go through it, isn't it? So there isn't really a negative to this. But anyway, hopefully none of this is brand new, but if it is, it's okay. Here we go. So in general, we originally, when we made numbers, right, we were like 1, 2, 3, 4, 5, and we were quite happy we had all these numbers, and then we came up with negatives, and then we came up with a 0, but at no point did we really think about what's in between numbers. And when people started to be like, oh, I'll have a piece of wood like this long, actually, can you split it into 3s? We were like, oh, what is that? And that's what fractions are used for, right? It's really what's in between numbers. Is there a way we can talk about it? One of the most famous ways teachers teach fractions is through pizza. Hopefully you're not hungry. And so the way it works then is it quite literally says, okay, this is 1/2. And the reason for that is because there's 1 slice of pizza out of the 2 that could have been there. Or there's 1 slice of pizza out of the 4 that could have been there, right? Or there's 3 slices of pizza out of the 8 that could have been there. I'm not drawing the whole thing. The top number says how many slices we have, so we either have 1 slice or 1 slice or 3 slices, and then the bottom number says how many equal slices the pizza was cut into, right? And it's important for it to be equal slices because that's the whole point of fractions. Okay. Now, it would be ridiculous if in real life we were talking about everything in terms of pizza. That's not how things work. So we actually call the top of the fraction a numerator, the bottom of the fraction a denominator, and this is the image I find more useful, where in the case of pizza, the top is the number of pizza parts we have, and the bottom is how many the pizza was cut into. But in general, numerator and denominator tend to be the words we use instead. Now, in general, I've said general like 4 times now. There are 3 types of fractions. We have the proper fraction, where I have cut my pizza into 5 and I'm going to eat 3 of them. That's fine. An improper, where I cut my pizza into 5 and I eat 9 of them. What? And then this one, a mixed fraction, where I'm going to have 2 big pizzas and I'm going to cut the last one into a third, into 3s, and then have 1 of them. Now, it is incredibly important for you to be able to switch between these 2 easily. And so for the first part of this lesson, we're going to talk about that. Now, to go from improper into mixed, what we're looking at is how many 5s go into 9, right? How many of them exist? And so in our case would be 1. And then how many is left over? So 5, 10 would be too many, which is why we got 1. And then how do I get from 5 to 9 is 4 with 5 left over, right? What's nice here is the denominator stays the same. And then the reason we got 4 is because how do I get from 5 to 9, right? So that's the idea. If you prefer words, here's words, because I know some people prefer that. So to turn an improper fraction into a mixed fraction, find out how many times the denominator goes into the numerator, so how many times the bottom goes into the top. That number is going to be that big number, the whole number. The remainder is going to be the new numerator, and denominator always stays the same. Always stays the same, because we're just converting, right? We're not actually doing any maths here. We're just kind of representing them 2 different ways. So find out how many times the denominator goes to the numerator. That number becomes the whole number. Remainder is the new numerator. Denominator stays the same. If you're like me, you're like, that's a lot of words. Can you show me some examples? Here we go. So here's 2 examples. So how many times does 4 go into 11? When you're working this out, you wouldn't do what I'm about to do, but I'm just going to go through it, right? So for a 4 times table, we have 4, 8, 12, and then that's too many, right? So it's 4, 8, 12, but actually, how many 4s go into 11 is only 2, right? Because I can't get to 12. So I'm going to have 2, and then how many do I have left over? Well, I got to 8, and I'm trying to get to 11. So how many do I have left over is 9, 10, 11, there's 3 there. So 3 out of 4. Cool. Somebody asked me, is there a reason I sometimes do diagonal fractions? No. Don't copy it. It's a bad habit. Okay. Convert 10 over 3 into a mixed fraction. Okay, how many times does 3 go into 10? It goes 3, 6, 9, and then obviously it goes to 12, but 12 is too many. So again, I've got 3, and then from 9 to 10, how many do I have left over is 1. So 3 with 1 over 3. Cool. Now, effectively, that was just division, right? It was like, how many 4s go into 11? That is 11 divided by 4, and that is 2 with 3 remainder, right? That's division. So to go one way is division, so weirdly enough, to go the other way is multiplication. So to convert a mixed fraction into an improper fraction, multiply the whole number with the denominator, add the numerator, and then that is the new numerator. Denominator stays the same, right? So multiply the big with the bottom, add the top, and then that is the new top. So leave the bottom. Here's an example, and you'll see some teachers, a lot of teachers do this. So they'll go 3 times 5 plus 2. Yeah, so like the times and the plus to try and remind you. So you know that 3 times 5 plus 2 is 15, 16, 17. So my answer is 17 over 5. Cool. What about this one? Same idea. I'm going to do 2 times 9 plus 1. Well, 2 times 9 is 18, plus 1 is 19, so that's 19 over 9. Cool. And then the last one, this is a question that comes up a lot, especially in the EQAO and stuff. They love throwing negatives in there, but literally, a negative is just a direction. So completely ignore the negative until the end, and do the exact same. Do 2 times 3 and add 1. So 2 times 3 is 6, add 1 is 7, that's 7 over 3. And then, don't forget the minus sign. There is no subtraction going on. There's no like anything special going on. It is just 2 times 3 plus 1 over 3. And then put a minus sign in front because it's just a direction, right? It's like me saying, I'm going to eat 2 1/3 pizza. Like that 2 1/3 pizza is gone, or 7 slices out of 3 pizzas have gone. And it's still the subtraction sign or minus sign is still there. Okay, if that made a complete sense to you, there are a bunch of questions there. I recommend doing them. I'm going to go through, I don't know, maybe just the top 3 in both of them, and then I'll flash up the answers, which are on the next slide. Have a go, make sure you're comfortable. This skill is incredibly important, especially, well, you're going to see why. So obviously we go through it for a reason. Pause the video. I'm going to do top 3 in both sections, and then have a go. Okay. Okay, so you should have seen how many 4s go into 15. If you know your 4 times table, it goes up to 12, so that is 3. And then there's going to be 3 remainder, right? Because 4, 8, 12, 13, 14, 15. How many 8s go into 61? That is going to be 8 times 7 is 56, so it's going to be 7. And then from 56 to 61 gives me 5. And then, oh no, there's a negative sign. Oh no, doesn't matter, right? Just it's going to be a minus sign in front. That's all that matters. How many 9s go into 56? Well, I know that 9 goes into 53. No, what? 9 goes into 54 6 times. And then that's going to give me 2 remainder, isn't it? Cool. What about at the bottom? This one here. I will put up the answers for the rest. I'm just not going to go through them all. So again, you're going to do 5 times 3, which is 15, plus 2, which is 17. And so it's going to be 17 over 3. You're going to do 2 times 10, which is 20, plus 1 is 21 over 10. And then you're going to do 6 times 9, which is 60. Add 9 is 69 over 10. Oh, did I forget anything? Oh, yeah, I forgot a negative sign. Who cares? Okay. But don't, as in I say don't, who cares? But I mean, obviously, put the minus sign there. Like, it does matter. Right, here are the rest of the answers. The only one where if you did have a go that you might have been like, whoa, I swear this is different, is this one here. You might have got 6 over 9 here instead of 2/3. All that they've done there is they simplified it, right? But we haven't talked about simplification, so it doesn't matter. Cool. Let me know if there's any questions you got wrong there. We can go through that later. Okay, multiplying fractions then. Right, this one of those multiplying fractions is one of those things that people find so easy that they forget how to do it because they can't believe it's that easy. And then our brains being our brains, we don't remember things that are that easy, and we kind of get confused with other stuff. So here is how you multiply fractions. You multiply the numerators, then you multiply the denominators. Yep, that's it done. Like, no, I mean, you should simplify if possible, but because I haven't taught this yet, I'm not going to simplify a lot of my answers and stuff. We're going to talk about simplification tomorrow. So, like, if you can simplify, great. But, like, I'm not that bothered right now. And then also, if it's a mixed fraction, it has to be turned into improper first, which is why we did the whole conversion things first. So, still the same idea. Multiply the top, multiply the bottom. Unless it's a mixed fraction, then convert them and then do exactly what I just said. So here's an example. Literally do 1 times 2, which is 2, then do 2 times 5, which is 10, and then you get 2 out of 10. And there's nothing wrong with that answer whatsoever. If you happen to recognize that both the 2 and the 10 are both even, i.e. they can divide by 2, simplification is just that. All you do is divide by 2. In this case, you can divide by any number, but it has to be the same. You divide by 2 for both and you get 1 out of 5. But if that doesn't make a lot of sense, that's fine. I'm not going over that massive detail today. We'll worry about that tomorrow. So there it is. That's as simple as that. Multiply top, multiply bottom. If you're like me when I was young, I would have said prove it. And so here's my very quick proof. If I've got 2/5 of a pizza and I split each of those pizzas in half, i.e. I times it by half, I basically end up with 2/10 of a pizza, don't I? Right? Because there it is, that one and that one makes the 2, and then obviously it's now being cut into 10, because I cut every slice into 2. And so that gets me 2 over 10, and that gets me 1 over 5, which is the simplified version of it. So that's not a actual maths proof, that's just a visual proof, so hopefully that makes a bit more sense for you. Cool. This example, does it matter if the numbers are really big? No, it doesn't. 1 times 9 is 9. 3 times 16 is 3248. And then, again, if you happen to notice they can divide by 3 on the top and bottom, and you get 3 over 16. Cool. Very easy, very simple. What about this one? Oh, no, it's a mixed number. Oh, no, it doesn't matter. Just turn it into an improper number, right? So 1 times 3 plus 1. 1 times 3 is 3, plus 1 is 4, so 4 over 3, times by 2 over 5. All I've done there is convert. And then multiply across. 4 times 2 is 8, 3 times 5 is 15. Woo, woo. Okay, cool. What about this one? Oh no, it's not a fraction. What do I do here? 5's not a fraction. Well, any number could be written as a fraction, right? Because 5 can be written as 5 over 1. And the reason we can do that is because 5 divided by 1 is just 5. So I'm not actually changing a number, I'm just changing the way it looks. And now that it's a fraction, I can just multiply the top and multiply the bottom. So 5 times 1 is 5, and 1 times 4 is 4. So it doesn't really matter. And you could convert that into mixed if you want to. Okay, so that's all the things I'm doing for multiplication. There are a bunch of questions there, just a few things to talk about. The top are easier than the bottom. Remember that if we have brackets next to brackets, it just means times. I'm going to go over these in 5 seconds. Off you go. Okay, so let's zoom in and do them. So, sometimes it zooms in and just sends it to the other side of the planet. I don't know what's going on. Okay, so for this one, 1 times 2 is 2, 3 times 3 is 9. The answer is 2 over 9. For this one, 2 times 4 is 8, 3 times 5 is 15. For this one, 3 times 2 is 6, 7 times 5 is 35. For this one, 1 times 1 is 1, 5 times 6 is 30. 3 times 2 is 6, 4 times 5 is 20, and then you could have turned that into 3 over 10, but again, I'm not going through how. And then this horrible looking thing, 5 times 9 is 45, 12 times 14 is 168, and then you can recognize they're both divisible by 3. Now, there are shortcuts in all of this, but I'm not going to show you why. And that gives me 56. So if you got 45 over 168 or 15 over 56, you're the best in the world. And then last but not least, these are obviously the harder questions. These are like a level 3, level 4 questions. Turn them into improper first. So remember, 1 times 4 plus 1. So 5 over 4 times 2 over 5. And then just multiply across to get 10 over 20. And then you can also simplify that to be 1 over 2 if you wanted to. Ooh. Again, try not to do too much at once. So in this case, just like turn them into improper first. Right, and then we can multiply across. So 2 times 2 is 4 plus 1 is 5, so 5 over 2. 1 times 3 is 3 plus 2 is 5, so 5 over 3. And then that gets me 25 over 6. You could convert that into 4 and 1 over 6. And in general, we should. If it starts off as a mixed, it should end off as mixed. But you won't lose marks in grade 9, probably. Well, me anyway, you won't. And then last but not least, turn this into a fraction. And then do 4 times 2 is 8, 1 times 5 is 5, and you're good. I said you won't lose marks for that. I mean, if the question says leave your answer in mixed, then obviously you don't get marks if you don't follow the rules, but you get the idea. Anyway, those are the answers for that. If everything made sense there, wonderful. Now we're going to talk about division. So, I appreciate the idea that I've spoken about pizza so far, and I've talking about KFC so far. If this was before lunchtime, or you haven't eaten yet, I am sorry. Here we go. So dividing fractions is basically the same as multiplying fractions, apart from there's one step that you have to do before it. And this step is beautifully shown in this diagram over here on the right. You have to keep the first fraction the same, so that's what we've done, right? The half stays the same. You change the fraction into a multiply, so divide turns to multiply, and then you flip the last fraction, so 1 over 4 becomes 4 over 1. Here's the words if you prefer words. Keep the first fraction the same, change the divide into a multiply, flip the last fraction. Again, if it is a mixed fraction, and then once you've done that, you're not done, right? You're not done, but now you just have a multiple. So now you can just do 1 times 4 and then 2 times 1, and exactly like we did before. So as I said, there's a step before just normally multiplying it. If it is an improper fraction, if it's a mixed fraction, you have to turn it to improper. All right, that's just the way it is. Okay, so here is an example and also a proof. So again, you keep that the same. That's supposed to be a k, 1 over 2. You change that to be a times, and then you flip that to become 6 over 1. Once you've done that, you're not done, obviously. You have to still find the question. And we remember how to multiply fractions. We just do 1 times 6, which is 6, and then we do 2 times 1, which is 2. 6 over 2 is fine to leave if you really want to, but remember that fractions are just division. So 6 divided by 2 is just 3. So in this case, there's no real reason not to just turn it into 3. Okay, here's your proof then. So remember the question said a half divided by a sixth, and that's what this is. This is a half, and this is a sixth. So it's saying how many sixths go into a half, and when it's shown like this, you can easily see it's 3. And that's the answer we got, isn't it? 3, right? So this kind of shows you that this is the way it works. This is what we do. If you really want to go into a massive amount of information about why division of a fraction is we keep change flip, and that's one of the reasons we do it. It's all to do with like two minuses make a plus and two divisions make a, yeah, you see what I'm trying to get at? Maybe, I don't know. Here we go. So keep, change, flip. Keep this the same, change this, flip this, so it becomes 1 over 8 times 4 over 1. If you multiply the top, you get 1 times 4 is 4. Multiply the bottom, you get 8 times 1 is 8. And then you could simplify if you wanted to get a half. But again, I haven't taught you that yet. Cool. What about if it's a mixed? What about if it's not a fraction? Oh no, it doesn't matter, right? Make it a fraction, 5 over 1. Keep, change, flip, 2 over 3 times 1 over 5. And then multiply across 2 over 15. Done. Cool. I'm not going to go through that one. Same idea. Okay, cool. So there are 9 questions there. Have a go. I'll go through them shortly. Okay. Here we go. So 2 over 5 divided by 1 over 2. So 2 over 5 times 2 over 1. Multiply them, you get 4 over 5. Easy. 1 over 7 times 3 over 2. So remember, it's just keep, change, flip. 1 times 3 is 3. 7 times 2 is 14. Done. 5 over 11 divided by 3 over 4. Don't forget to keep, change, flip. So that gets you this. And then that gets you 20 over 33. Well, this gets you 1 over 6 times 4 over 1, which gets you 4 over 6, which you could turn into 2 over 3. This gets you 3 over 10 times 7 over 6, which could get you 21 over 60, which you could, if you've seen it, get you 7 over 20. And then last on this line, 9 over 14 times 6 over 5 gets you, 9 times 6 is 54 over 70. You probably could simplify that. I'm not going to. And then turn it into improper. 1 times 4 plus 1 gets you 5 over 4 times 5 over 2. In general, I don't recommend doing too much at once, but I didn't think that was that bad. And that gets you 25 over 8, which again, you could turn into 3 and 1 over 8 if you wanted to. In this question, I definitely wouldn't do too much at once. So I would turn it into improper first. So 2 times 2 plus 1 is 5 over 2. 1 times 3 plus 2 is 5 over 3. And that's division still. So then turns it into times. Gets you 15 over 10, which you could make as 1 and 5 over 10. And then you could turn that into 1.5. And then last but not least, make this a fraction. Make it 4 over 1 times 5 over 2. Get your answer as 20 over 2, or just call it 10. Okay, that is the end of the lesson. So we've went over converting fractions from converting fractions from improper to mixed, and vice versa. Multiplying fractions and dividing fractions. And if that all made sense, wonderful. Thank you.